Good morning. I'm Spot On Weather meteorologist Matthew Euler, and welcome to the Spot On Weather 2021-22 winter forecast. This is part one of the winter forecast video. I will be doing this into two specific parts, mainly focused today on past winter weather on up through a discussion on the returning La Niña. And then I will move into a teleconnection discussion in part two, the other teleconnections such as the MJO, as well as PNA, EPO, polar vortex. All of those discussions will be held off until part two of the video. So let's get right to the presentation today. A little humor here to start you off on the winter weather forecast this year from the movie A Christmas Story. And of course we always remember this scene where he was dared to stick his tongue on a colder pole, and of course his tongue got stuck on that pole. So I thought this was a pretty good opener here on this year's winter forecast. All right, so let's take a look at the 2021-22 winter forecast overview. Again, today in part one, we're going to cover the 2020-21 winter season review on a global, national, and local level. And then I'm going to get into a discussion on La Niña. And then in part two, we'll cover the rest of the material, the teleconnections discussion with the focus on the MJO, the PDO, EPO, the AO, NAO, and PNA. We'll talk about the stratospheric polar vortex in the next part two video, as well as sea surface temperature anomalies, solar activity, and the weighted forecast factors in part two, as well as my final thoughts on the upcoming winter. And then finally, this year we added some forecast weather maps for where we expect the coldest and warmest temperatures to set up across the United States, as well as precipitation anomaly forecasts. Now keep in mind that this winter forecast is for meteorological winter, which runs from 1 December to the 28th of February. All right, so I'm just covering meteorological winter on this preview. Let's start off and look at some past winter weather. Let's go back to last winter season, December 2020 to February 2021. It was really an interesting winter last season. We were mainly influenced by three main climate drivers in the United States. We had a La Niña. We also had a fairly persistent negative North Atlantic oscillation, or NAO, where we had this just continuous high latitude blocking going on, especially on the North Atlantic side. We did have some blocking also into the Gulf of Alaska, into the North Pacific side as well. What this did, this persistent high latitude blocking, eventually led to this weakening stratospheric polar vortex. And we'll never forget the end of last winter season in February. The impacts were felt over the central U.S. as well as down into the deep south in parts of Texas, for example. We also, if you take a note here, the maroon shading on the graphic on the left shows very warm temperatures over northeastern Canada and the Arctic as a whole once again on the North American side. One of the main headlines again was that extremely frigid air that settled into the central U.S. all the way down to the Texas Gulf Coast in February. And we're talking about just record-breaking cold, snow on the ground in Houston, Texas. And that was mainly due to a collapsing or a weakening polar vortex. Once that weakened in January, that really set the colder air in motion from the Arctic into very anomalous locations, locations that normally don't get such cold. February was an exceptionally wet month for the Mid-Atlantic, especially across southeastern Virginia. I remember it well. The yard was a complete mess as far as, you just go walk in a yard and it was so wet that your foot would sink into the soil. We had a baroclinic zone that set up along the Mid-Atlantic between the extremely cold Arctic air over the central U.S. and then the milder air, usually located over the Gulf Stream ocean current or the western Atlantic Ocean. So we sat in that major contrast boundary between extremely cold air to the west and milder air to the east. And so whenever you get these strong temperature contrasts, that generally leads to a strengthening polar front jet stream. You get more upper level dynamics, and you also get more frequent cyclogenesis or development of storm systems, one after another. One other note before I move on, if you look at the blue shading there in the graphic on the left, you'll notice how much colder than normal it was over parts of Siberia as well last winter. All right, so for the United States as a whole, we had a fairly normal winter across the Mid-Atlantic. But as the United States as a whole, you look at the maroon shadings; those indicate above normal temperatures. The blue and green shadings below normal temperatures. I'm going to break down the months here. December 2020 is on the left, just showing where the warmest and coldest temperatures were across the United States. It was about 3 to 4 degrees below normal across southeast Virginia. You go down further down the coast to the parts of South Georgia and Florida. You're looking at about 4 to 5 degrees below normal for annual mean temperatures. Much warmer conditions across Montana into North and South Dakota last winter. And even milder conditions, slightly warmer than normal across the upper Midwest into Wisconsin, Illinois, as well as Iowa and Indiana. For the month of January on the right, you can see the similar area, very warm and above normal across North Dakota, northern Minnesota, parts of Montana into South Dakota. That seemed to be the bullseye where the warmest temperatures were. Slightly cooler than normal conditions across the desert Southwest, Utah, Arizona, into New Mexico and West Texas. And there was a little patch of slightly below normal temperatures in January across Southeast Virginia and Northeast North Carolina. One thing you will notice is the lack of above normal temperatures across the southeastern U.S., extremely above normal temperatures, that is, across the southeast U.S. and the mid-Atlantic. That is indicative of the absence of that southeastern ridge there. So we didn't really see the southeastern ridge very much last winter. In February 2021, look at these temperature anomalies. This is crazy. Look at the difference between December on the left and January on the right, and then we go to February 2021 and look at the purple shading. Extremely cold temperatures, anywhere from eastern Montana down into the central U.S., eastern Nebraska, Iowa, into northern Illinois, and further southward into Missouri, Kansas, Oklahoma, on the order of 12 to 13 degrees Fahrenheit below normal. Look at Texas. We had that green shading indicating generally 5 to 7 degrees below normal temperatures all the way down to the Gulf Coast there. Now you'll notice over the Mid-Atlantic and the East Coast in general, the blue shading, that's generally indicative of 1 to 3 degrees below normal temperatures. It wasn't excruciatingly painful, but it was slightly below normal. One thing to note here too is how the coldest temperatures remain generally to the west of the Appalachian Mountains. All right, and this whole collapse of very cold air, this unusually cold air, was a result of the collapse of that the stratospheric polar vortex. And so it played a huge role in the weather into the late portion of winter last year, especially into February. Now, looking locally in southeastern Virginia, specifically in Virginia Beach, I went back and I looked at my records to see how the average temperature, that mean temperature, how much above or below normal it was in general, going back to September 2019. So we're going back a couple years, and you'll notice the departures from normal here in temperatures. So September 2019, Virginia Beach finished at 2.6 degrees Fahrenheit above normal. In October 2019, 3.5 degrees Fahrenheit above normal. November 2019 was the really rare exception here at minus a 4.2 degree below normal departure. And we actually had in November 2019 rain changing over to snow one late November evening. I believe it was around the 19th or 20th of November in 2019. Well, we had a cold rain during the day, a strong Arctic front moved through, and really dropped temperatures that day. And I can remember driving back on the interstate that evening, and it was snowing. We didn't have any accumulation, but that was pretty impressive for the temperatures to be that cold that early across southeastern Virginia. Now, December 2019, back to above normal, 3.4 degrees Fahrenheit above. And January 2020, wow, what a warm winter that was. If you look at January 2020 and February 2020, those 2 months, we had a 6.3 degree Fahrenheit above normal departure in January, and then in February 2020, 5.2 degrees Fahrenheit above normal. And the overall winter season, the 2019 to 2020 winter season, was 5 degrees Fahrenheit above normal for Virginia Beach. I mean, it was one of those winters where you were just asking yourself, where is winter? I mean, is this really winter right now? Never really got very cold that winter. September 2020, now we're moving forward to the fall of 2020. In September 2020, we had a 0.2 of a degree departure below normal. In October 2020, things warmed up again above normal by 2.4 degrees Fahrenheit. November 2020, 3.6 degrees Fahrenheit above normal. December 2020, just slightly under a degree Fahrenheit above normal. But in December 2020, we started seeing signs this past December of a weakening polar vortex. Plus, we have the influence of La Niña. January 2021, just slightly above normal, 0.7 degrees Fahrenheit. And we also received our one and only accumulating snow of the winter season in Virginia Beach, where it was 3.5 inches of snow fell late on the evening of the 27th into the morning of 28 January. February 2021, we were slightly below normal, just a half a degree Fahrenheit. Overall, February 2021, because of that very active storm track with the very cold Arctic air out to the west and that milder air over the Gulf Stream, with that baroclinic zone setting up along the mid-Atlantic and the East Coast in general, it was storm after storm. We finished 4.1 inches above normal for the total precip in February. And by the way, that monthly total was over 7 inches of precipitation in February 2021. So really impressive. So if you look at the comparisons, what I try to do in my analysis is I try to look at past data and try to correlate it with specific temperature regimes. So for example, let's just say you're looking at this data here and you say, okay, well, does a warm fall generally lead to a colder winter? Or does a colder fall lead to a colder winter, or vice versa? You know, I'm looking at the data to see if there's any kind of things that just really pop out to really indicate as far as the forecast for the next winter season. And overall, these months going back to September 2019, these fall months and the winter months have pretty much been above normal for Virginia Beach. Outside of that November 2019, 4.2 degree Fahrenheit below normal departure, yeah. And last winter in general, December 2020 through February 2021 for Virginia Beach was pretty close to normal. We really didn't see the southeastern ridge build into the mid-Atlantic and result in just some crazy anomalously warm temperatures like we did back in January of 2020. In January 2020, we had a record strong polar vortex. The polar vortex remained strong all winter long, and really no weakening, which resulted in a milder winter. And plus, we had El Nino conditions on top of that. So, very warm fall at the bottom there. The analysis yields a very warm fall outside of the November 2019, cooler than normal period, and then winter 2019-20, extremely mild. And then we had a mild fall in 2020 last year, followed by near average winter temperatures. So I like to look at this again for comparisons to see if we can correlate any specific data or any specific patterns in conjunction with my winter forecast. Here's just the graphical look locally of last winter. This is December 2020. The blue spikes here are just showing you, how high or low the air temperatures got throughout the month of December last year. This is typical where we see a wide range of temperatures across the Hampton Road cities, where you may see a day with 70 degrees and then a strong cold front comes through and that temperature can drop on the order of 20 degrees the next day. So you get these strong cold frontal passages, you get these occasional warm-ups. So this is quite normal. You look at the temperature ranges for December 2020, anywhere from about 23 degrees Fahrenheit on the morning of the 28th of December, all the way up to a high of 70 back around the 14th of December. So it can be fluctuating quite a bit here. January 2021 for Virginia Beach. You notice the general temperature trend. The average temperature trend is much colder, which we would expect for January, one of the coldest months of the year here in Virginia Beach. And in general, your range is 62 in early January, all the way down to just about 25 degrees about 10 days later from that warm point. And so you kind of see the ups and downs and the fluctuations, again, very normal. Now, when we got the snow, that would be back the right-hand side of this graph. You'll notice how the temperatures dropped off fairly significantly at the end of January on the right-hand side of the graph. Generally from about 36 degrees on the 28th, and they dropped down to about 25 degrees on the morning of the 29th, and that was after the snow. February 2021 for Virginia Beach, it stayed fairly cold, mainly below 50 degrees Fahrenheit. There were a couple spikes in the first week of February where the high temperature reached above 55 degrees Fahrenheit. In general, though, towards middle part of February, this past winter season, we saw a major warm-up there around the 16th, where high temperatures ranged above 65 degrees Fahrenheit. And then a major drop-off as a strong cold front came through on the 17th of February, where temperatures dropped to the low 30s overnight. And then you just see a little bit of a colder period between the 17th of February to the 22nd of February, where the high temperature did not rise above 40 degrees. And then it got milder towards the end of the month. For the winter season precip, this is December, just kind of showing you the total precipitation there denoted by the blue line. The blue solid line indicates the total monthly precip, just below 4.5 inches for the month of December. We look at January 2021 in Virginia Beach. The total accumulated precipitation was about 3.6 inches. And then February was very wet, as I mentioned, where we're looking at, 7.5, some locations, parts of Virginia Beach, up to 8 inches of total precipitation in February of 2021. It was a case where we would have a storm every 2 to 3 days there for about 2 weeks. And I remember how, it was cold, but just not cold enough if you want to see winter weather in Hampton Roads. It was just one of those nasty, cold, rainy periods that we frequently get here in the winter season. Here was a look back at the accumulating snow back in late January of 2021. This was the 27th of January. You'll notice the snowfall totals are on the left. And in the area in southeast Virginia, we generally got on the order of 2 to 4 inches of snow overnight. It really started falling late on that evening of the 27th of January. I can remember going to sleep, and there, nothing was falling from the sky yet. There was a fairly potent shortwave trough, which was located to the west, over the western parts of Virginia when I did go to sleep. And then woke up on the morning of the 28th, and the upper right-hand picture kind of shows you what it looked like around Virginia Beach, where we got a pretty good burst of snow overnight. And when I woke up that morning of the 28th, I had over 3 inches of snow. So this was really the main snowfall event for the winter of 2021. No major big snowstorms, but it was just cold enough to be snow and stick, as you can see on these roadways, the picture in the upper right, as well as on cars. Now, the snow potential could have been more. I mean, if that core of the coldest Arctic air would have shifted to the East Coast, we would have been talking about multiple snowstorms for the Mid-Atlantic and southeastern Virginia. But that just didn't happen. The number of hours below freezing is on the left in the purple shading from the week February 12th to the 19th, 2021. And you'll notice some of those 144 hours plus below freezing all the way, from the west, the Appalachian Mountains into the Midwest, the northern plains, down all the way down into Texas. The core of the Arctic air, though, just stayed west of the Appalachians and the East Coast. We just couldn't get it all the way to the East Coast. And again, that baroclinic or storm zone set up along the leading edge of the Arctic air, where we had that sharpest contrast in temperatures. That really, the upper atmosphere tapped into that temperature contrast and provided that kinetic energy. The jet stream really amped up, and we got a lot of storms. Again, this occurred resulting in a just warm enough scenario for cold rain across Hampton Roads cities. Very close to average temperature-wise, and was the 8th wettest winter on record, by the way, overall. The warmest temperature that occurred was 71 degrees here in Virginia Beach on the 24th of December. I remember Christmas Eve last year. We had a strong cold front approaching, and we had a potent line of thunderstorms that moved in and actually produced a tornado in Suffolk, Virginia. And after that cold front moved through on Christmas Eve, it got really cold for Christmas and the day after Christmas, where we had temperatures at 26 degrees on December 26th in the Norfolk area. So again, the snow potential could have been there, but the coldest air stayed to the west of the Appalachians and didn't quite make it to the East Coast. Okay, here's a look at the sea surface temperature anomalies in the Nino 3.4 region during the 2021 winter season, showing the blue shading indicating below normal temperatures. So we have those cooler than normal temps across the equatorial eastern and central Pacific Ocean, which is quite common of a La Nina. The graphic on the right shows the variation between warm El Nino years and colder La Nina years. The red spike indicating El Nino years and the blue spikes indicating La Nina years. So we're in a period right now where we have La Nina forecast once again this next winter. So overall, La Nina is set to return for winter 2021-22. The latest outlook from the NOAA Climate Prediction Center is indicating a greater than 70% probability of La Nina conditions returning. And this is defined overall by this negative oceanic Nino index, ONI, less than or equal to 0.5 degrees Celsius. The Climate Prediction Center considers La Nina conditions to occur when monthly Nino 3.4 sea surface temperature departures meet or exceed minus 0.5 degrees Celsius or cooler, along with consistent atmospheric features. And this must be forecast to persist for 3 consecutive months. If you look at the bottom right-hand graphic there, it shows you a breakdown of the Nino regions, with the Nino 3.4 region there at the bottom right in the center of the graphic. So La Nina is forecast to return this upcoming winter 2021-22. These are different models. This one on the left actually is a CFS version 2 forecast model for the sea surface temperature anomalies in that Nino 3.4 region, showing a fairly significant drop-off between late September into October, November, December time period, where the sea surface temperatures are forecast, according to the CFS V2, to drop but basically around negative 1.3 degrees Celsius. And the graphic on the right kind of shows you the prediction. The blue shading, again, indicating below normal water temperatures in the equatorial eastern and central Pacific Ocean, indicative of the La Nina. We look at the graphic on the left showing the sea surface temperature anomalies in degrees Celsius, courtesy of the Tropical Tidbits website. As of September 16th, we had a departure of minus 0.3 degrees Celsius in that Nino 3.4 region, and the trend is further cooling, as you noticed here, by the trend, by that line bending downward. The graphic on the right shows the La Nina forecast probability by the blue bar. Gray bars, by the way, the gray vertical bars indicate neutral conditions, and the red bar indicates El Nino conditions. So if we look at the months of October, November, and December, we're just under an 80% chance of La Nina conditions. For the months of November, December, and January, very similar, just over 70%. So we have a fairly high probability that we're going to see La Nina conditions across the eastern and central equatorial Pacific again this winter. What does a typical La Nina winter look like? This shows the general weather patterns across the United States. We generally have a blocking high pressure in the northeastern Pacific, with the polar jet stream directed from the Gulf of Alaska over parts of the Pacific Northwest, where the conditions are typically wetter than normal. And then the jet stream the polar front jet tends to dip into the Midwestern U.S. across New England. We generally have warmer and drier conditions across the Mid-Atlantic region and the southern U.S., with the main storm track basically following this jet stream axis across the Pacific Northwest through the upper Midwest into New England. And anywhere north of that blue line, that polar front jet stream, we typically have colder than normal conditions, with the coldest of temperatures focused on western Canada and parts of the northern plains. This is a typical La Nina winter. Now, keep in mind, again, I say this every year during the winter outlook, no two La Ninas are ever alike. All right, so what I really want to get at here is typical La Nina winters are shown here by these graphics, courtesy of the Climate Prediction Center. You notice on the upper left-hand graphic there on the slide, you see the blue shading that indicates below normal temperatures, the yellow or orangish shading above normal temperatures. And so you generally get colder than normal temperatures, generally over the northern plain states during La Nina winters, as well as the Pacific Northwest, and milder than normal conditions from Texas through the southeast up to the Mid-Atlantic. Precipitation anomalies, we take into account all the La Ninas of the past, the composite. We typically see wetter than normal conditions across the Midwest and the Ohio Valley, drier than normal conditions across the Mid-Atlantic, especially dry down along the Gulf Coast as well as Florida. And snowfall anomalies there on the bottom left generally show, the blue shading shows above normal snowfall across locations such as the Pacific Northwest, the northern plains states, Montana, and in the upper Midwest, Minnesota and Wisconsin, as well as New England, Maine, New Hampshire, Vermont. And below normal snowfall, generally across Pennsylvania down to western Virginia. And that pretty much wraps up all the composites, all the past La Ninas, the temperature, the precip, and the snowfall breakdown. But it does depend on the strength of the La Nina. Do we have a weak La Nina, a moderate La Nina, or a strong La Nina? Last year we bottomed out at a moderate La Nina, and then later in winter, by late winter, the trends in the water temperature anomalies in that Nino 3.4 region began warming. Strong La Nina episodes are going to lead to much more pronounced dry, mild winters across the Mid-Atlantic. So this is important to see how strong the La Nina is forecast to get in the winter outlook. Weak La Nina episodes, on the other hand, they lead to near average temperatures and precipitation across the Mid-Atlantic. I did put in bold here the categories of the La Ninas, whether it's a strong, a moderate, or a weak. Those are the temperature anomalies, the water temperature anomalies in that Nino 3.4 region. So if it's 1.5 degrees Celsius below normal, or even colder than that in that Nino 3.4 region, we have a strong La Nina. A 1 degree Celsius departure from normal is a moderate La Nina, and then a weak La Nina would only be a half a degree Celsius below normal in that Nino 3.4 region. So it does matter. The strength matters in the sensible weather. Now be mindful that there's other teleconnections, which I'll discuss in part 2, which can be more dominant, canceling out the effects of La Nina. However, the stronger the La Nina, the greater its influence on U.S. weather. Here's a comparison of temperature departures between a weak La Nina on the left and a strong La Nina on the right. And what a difference this is. The yellow and orange shadings, that graphic on the right, indicate much above normal temperatures. And you see how mild it is from the southern U.S. All the way up through the mid-Atlantic, which is cool, with the coolest temperatures during strong La Nina actually out towards the western U.S. For a weak La Nina on the left, you'll notice the white coloring, white shading indicates near normal temperatures. So again, a big contrast and difference between a weak versus a strong La Nina. Here's La Nina winners of the past. Again, strength dependent. I'm showing you last winter's sea surface temperature anomalies on the right with the blue line indicating how far below normal those water temperatures were in the Nino 3.4 region. Things bottomed out generally the first couple days in November, where we were in exceedance of 1.5 degrees Celsius below normal in the water temperatures. But then if you notice on that bottom right-hand graphic, as we got into mid to late January, there was a recovery, a slight warming in those water temperatures. And then the graphic on the left shows the warm and cold periods associated with a strong, moderate, and weak La Nina going back to 1950. The maroon or red shading above normal and the blue shading below normal. All right, that wraps things up today on part one of the Spot on Weather winter forecast for the 2021-22 season. I'm going to kick off right here on part two, so stay tuned for the next video. We'll start off with talk about the Madden Julian oscillation and its role in our winter weather. All right, thank you so much for watching, everybody. I wish everybody a happy Friday. Hope you're enjoying your day wherever you are. And again, stay tuned for further information, part two of the winter weather outlook from Spot on Weather, where we do accuracy through precision. Take care, everybody.